Welcome to the first edition of the vNews for 2022. In this edition, we'll be talking about two aspects of our work. The first is the downhole LIBS tool, which is a downhole assay technique being led by CSIRO, where not only do we have two different instruments in laboratories simulating analyses, we also have a simulated drill hole in which we're putting our tool down in the second phase of MINEX and looking for exciting outcomes. The second part of this vNews is the application of all of our research in different areas, geological and technical, into the National Drilling Initiative, the NDI, which is being undertaken in South Australia under the auspices of the Geological Survey of South Australia, where we're deploying the coil tube rig and applying much of our learnings from phase 1 while we carry on into phase 2.
The first real-time downhole assay prototype based on LIBS technology has reached the first stage of real-world testing, which is analysis of a simulated drill hole in the lab based on real lithologies from the field. The very ambitious aim of developing a novel real-time downhole elemental analyzer has reached an important milestone: actual testing in a simulated laboratory drill hole. The four main parts of the project that have been progressing in parallel, which are the LIBS hardware, LIBS calibration from real lithologies, dual spectrometer software, and data analysis and modelling, are now sufficiently advanced that they will be incorporated for the first time into a real-time downhole analysis platform.
The LIBS hardware, laser, optics, and spectrometers has been incorporated into a very narrow probe that has undergone a variety of tests and is now ready to be lowered into an accurately characterized set of drilled ore blocks and will allow elemental analysis of a vertically oriented drill hole. The experimental setup allows for a range of contaminants to be introduced, as would be expected in a real drill hole.
The 21 accurately characterized ore blocks have been evaluated by various independent analytical techniques and can be assembled vertically into a synthetic drill hole and used to compare the results obtained by the downhole prototype. Part of this work also involved developing LIBS calibration for major and minor elements in our second LIBS lab at UniSA, further strengthening our understanding of LIBS analysis of typical lithologies. The data analysis and modeling aspect of this project has a range of novel components, incorporating artificial intelligence and machine learning. LIBS spectra will be degraded to various degrees by typical drill hole contaminants, and modeling the changes will give us an ability to accurately reconstruct the underlying composition. Finally, bespoke software that allows dual acquisition, control, and analysis of the dual spectrometer hardware are now at the beta testing stage, allowing spectral data to be instantly stored and handled remotely. The ability to obtain real-time elemental composition of a deep drill hole will dramatically reduce the time taken for the analysis to be incorporated into a commercial exploration campaign. For the first time, it will allow the results of one exploratory drill hole to directly influence the decision for the placement of subsequent drill holes.
One of the broad aims of the National Drilling Initiative is to open up these undercover and frontier areas and encourage mineral exploration to tackle areas that they've not tackled in a while or not tackled ever. Kicking off about 2 years ago, we conducted a legacy data review and a bit of a gap analysis about the state of geological knowledge about the area. We created a geological map, and we culminated a drilling program to really test and try and improve that geological map. That kicked off in about September 2021. At that point, we had a conventional diamond drilling, mud rotary and diamond drilling campaign of 7 holes. 4 of these were twinned with the MINEX CRC CT rig, where this was really deployed for the first time in a proper greenfield setting. The new additions to the CT rig, such as the selective coring tool, was really tested in that part of the campaign in some of these twinned holes and is really delivering excellent results. To date, we've had 7 holes drilled with a conventional diamond and mud rotary rig. We've twinned 4 of these with the CT rig. And then in our northern drilling campaign, which is about 200 k's northeast of the town of Burra, we've drilled 13 holes to date. And these are virgin holes in new ground and really exciting frontier territory. We had 2 geographic regions that we wanted to test with the drill rigs. So one being in the central Murray Basin between the town of Karoonda and Loxton, drilling into some interesting geophysical domains that look like they might be volcanic belts. So we managed to test those and map out those undercover with a drill rig, which was fantastic. And then after Christmas, kicking off in late January, we drilled a couple of 100 kilometres northeast of the town of Burra into the sort of marginal edge of the Murray Basin, where cover's a little bit thinner, the geology is a little bit more unknown. So this is targeting geophysically defined belts coming across from New South Wales. I think the CT rig's been absolutely fantastic on the program. It's been able to drill quickly through difficult and challenging lithologies, sort of saturated sands and muds, and really successful holes. On the end of a lot of these holes, we've managed to drill a 3-metre diamond interval of core, which was really outstanding for the CT rig to be able to deliver that. So really the big picture for us is to be able to supply mineral exploration or explorationists with a conceptual geological model to take to the frontier region to be able to explore effectively and efficiently, especially for the northern part of the Delamerian basement underneath the Murray Basin. Really, deposit styles weren't really known. There are no actual deposits or prospects out there, so really we need to build up the baseline geological data to be able to go into these regions and explore properly. As a geologist, you go into the field wanting to change maps, wanting to build maps, wanting to understand more, and I guess there is a real great unknown. To be able to have a look and have your best guess at what's underneath there and be able to actually test that and build a story around it is, yeah, it's exciting for me.